Welcome back, class. So, chapter 5's not been so bad yet, right? So, let's talk about how we are following energy as we are breaking stuff down. What is important here is electrons can carry energy. They can be bounced up to a higher state where they're just carrying energy. So, we are going to follow electrons so that we can follow the energy. So when something is losing electrons, or if it is gaining electrons, it is losing or gaining energy. Oxidation, admittedly a bad term because it came from before we really knew what was going on. Oxidation is when electrons are removed. So it's releasing that electron, releasing energy. So as we are breaking down a molecule of sugar, we are pulling electrons out of it. We are oxidizing it so that we can pull that electron out of it. If one thing is losing an electron, that means something else is picking up an electron. And if you remember, electrons have negative charge. So picking up an electron means your charge is getting more negative. So it's reduction. So its charge is getting reduced because it's picking up electrons. So lose an electron, oxidation. Here molecule A has an electron, it loses it. At the end you have an oxidized version of A. Here you have molecule B, it picks up the electron. At the end you have a reduced version of molecule B. Because electrons don't just disappear or appear magically on their own. Whenever there's an oxidation, there's a reduction linked to it. So these are called redox reactions. Now, because electrons have a negative charge, often they don't move by themselves. Often when the electrons move, they're also going to carry a proton with it. That proton is also referred to as a hydrogen atom, an H+. And so redox reactions are also often linked to dehydrogenation. Dehydrogenation is when you lose those protons. NAD plus is going to help a lot of enzymes function because it'll be able to accept those hydrogen atoms so that things can be oxidized and reduced because of NAD. So here NAD is going to pick up electrons, pick up protons, and become NADH, and so it'll carry one of these hydrogens, have another hydrogen kind of on its own. So if it has picked up two electrons, which version is more oxidized, which version is more reduced? NAD plus without the electrons, or NADH with the electrons? So with the electrons is the reduced version, without the electrons is the oxidized version. Here is some organic molecule. We'll just say it's sugar. Here's sugar with electrons, sugar without electrons. The sugar without the electrons is oxidized. With the electrons is the reduced form, okay? So be able to describe oxidation, reduction, and dehydrogenation. I probably just lost about half of you. So pause, go back, watch it again, take notes, make this make sense before you go on. Okay, then somehow at the end of all of this, we're also going to have to be making ATP. So ATP is going to be made when you take ADP, adenosine with two phosphates, a whole bunch of energy, and a phosphate group. Use that energy to throw this phosphate onto these other two, and you make ATP, adenosine with three phosphates. That's how we make ATP. There are three different types of phosphorylation. One is substrate level phosphorylation. So that energy to throw that phosphate on comes from another organic molecule. So you're going to rip the phosphate off of something else and use that energy to throw it onto ATP. So here you have some organic molecule with a phosphate on it, and you have a molecule of ADP. You rip the phosphate off of here, releasing energy. That energy is used to stitch it onto ADP, and now you have ATP. Oxidative phosphorylation is when we phosphorylate things through redox reactions. So that energy of those energized electrons is used to make ATP. Oxidative phosphorylation is what happens in the electron transport chain. It does not happen anywhere else. So if we are talking about the Krebs cycle, if we are talking about glycolysis, we are talking about substrate level phosphorylation. If we are talking about the electron transport chain, we're talking about oxidative phosphorylation. That energy comes from electrons. In photophosphorylation, the energy to phosphorylate ATP comes from light. We're not talking about photophosphorylation at all because we're not talking about phosphorylation. But you need to be able to tell me photophosphorylation makes ATP with energy from light. Okay, so you can outline those three ways that ATP is generated. You can describe to me what oxidation and reduction are. You are going to rewatch this video until those concepts make sense to you. Read your textbook, maybe watch some of those extra videos there, but you need to make this make sense today. Okay, I will see you later. Please let me know if you have any questions. Bye.